Hello, guys. Good afternoon. So, today, on the occasion of Holi, we are going to try to solve a super hard geometry plus greedy based problem, which was recently asked in the online assessment of BNY Mellon. So, people are chilling on Holi, but I don't get the chance to do it because my students always surround me with harder and harder problems. So, this is the link to the problem. Everything will be in the description of this YouTube video. So, guys, this is basically the problem. The name of the problem is line game. I will explain in short what is this geometry problem trying to convey. So, the problem is saying that you are given many horizontal and vertical lines. Okay, you are given many horizontal and vertical lines like this. Okay, 2D lines, xy coordinates. You are given the start point of each line, and you are also given the end point of each line. Okay, so like this, you are given many horizontal and vertical lines. Now they are saying find a point in this 2D in this 2D graph. Find a point such that the sum of distances of all the lines from that point is as minimum as possible. Okay, so let's see how can we solve this problem. Let me open Google Doc. Yes, I have. Let me first define what the problem is saying. I am recording this solution for my students, but I might upload it on YouTube as well. So let's see. Let me name it as BNY Mellon. So, guys, the thing is that the question is saying that you are given. Link to this document will also be in the YouTube description. You are given multiple horizontal slash vertical lines on a 2D plane, on a two-dimensional plane. So how is a line defined? Line L is nothing but defined by four coordinates. They are x1, y1, and x2, y2. Okay, so x1, y1 is the starting coordinate of the line, and x2, y2 is the end coordinate. So x1 y1 is the starting coordinate and x2 y2 is the end coordinate. We are given multiple lines like this. They are saying find a point on the 2D plane such that the distances from all sum of distances from all the lines is as minimum as possible. So if we check the case given to us, if this example we check, there is this one line starting at 0 comma 0 ending at 2 comma 0, then there is one line starting at 2 comma 0 and ending at 2 comma 3, then there is a line which is starting at 3 comma 1 and ending at 3 comma 4. Okay, so for this problem they are saying that the answer is coordinate number 2 comma 1, because the distance of 2 comma 1 from the first line is also 1, the second line is also 1, and the third line is also 1, so the answer is 3. So 2 comma 1 coordinate is giving us the minimum answer, possible answer, which is 3. So how do you calculate the distance of a line, like distance of a point from the line in this particular case? So if a line is something like this and your point is here, so all you have to do is you have to calculate that vertical distance. In case your point is like this, so the minimum distance will be nothing but the horizontal distance from this point to the start point of the line. Okay, so there are always 2 points, like start points and the end point. If your point is somewhere like here on the left or right, obviously you will have to add that, okay, that distance from the start and distance from the end. And if it is somewhere down, then just the vertical distance is enough. Okay, but as we can see, let me check in the problem. Let me check once more. Okay. So they are saying the distance is the total Manhattan distance. Okay, Let me check what they have sent. The distance, okay, the line segments represent the distance is the Manhattan distance. Okay, okay. So let us think how can we solve this problem. Suppose what would happen, like say if the line, if this is here, this is here, and the point which you are trying to select is here, then obviously we will take this distance only. Okay, we'll be taking this distance only. Say this is x1 and say this is x2. Okay, okay, got it. Cool, nice. So, guys, the thing is that they are telling us to find the minimum possible sum of distances of the point from each and every line. Okay, so for that, let's try to make this problem a bit simpler. At this point, it has gotten too much complicated for us. Okay, so let's just imagine we did not have any y coordinate, we only had x coordinate. Okay, we only had x coordinate. Okay, x line. So there is a line which starts at x1, ends at x2. Then there is a line which starts at x3 and ends at x4. So what we can do is solve the answer for x part and y part individually and then add the final answer. So solve the answer for x part individually. Just imagine there is no y coordinate. Okay, let's just think that there are only x coordinates. Okay, so we start at x1, we end at x2, then there is other line which starts at x3, ends at x4. Now if I give you a task and tell me that point which will have the minimum distance from both of these lines, then like if you say that okay, this point P has the minimum distance, so what will be the distance? The distance will be this, the closest distance from here, which is P minus x2 plus, obviously whatever point it is, it will be lying somewhere between x2 to x3. Okay, plus x3 minus P, x3 minus P. So the answer is if you cancel the P, you will get the answer is nothing but x3 minus x2. X3 minus x2 means the point will be somewhere in the middle of x2 to x3. In this particular case, the point will be somewhere from x2 to x3. So this signifies that the answer is always at the end point of some line. Okay, solve the answer for x part individually. Now it is known that the answer always lies on some end point of some line. Okay, guys, that point which we are trying to find, which the point which we are trying to find, which will have minimum sum of distance from all the lines, will always lie on some point, will always lie on some end point of a line. You can prove this in different ways. Okay, guys, this problem is way too hard, so that's why I'm not explaining each and everything in detail. I'm assuming that only intermediate and pro people are watching this video, but still let me explain for beginners as well. So guys, this example taught us that the point should be like either on x2 or x3 for this case. Now let's say we had the three lines like this. Okay, one starting at x1, then x2, then x3, then x4, then x5, then x6. So one line is here, x5 to x6, one line is x3 to x4, one line is x1 to x2. Obviously the answer will be either from x2, the optimal point should be either from x2 to x3, or it should be a point from x4 to x5. Why? Because again, if you take a P here, What will be the answer? The answer will come out to be like p minus x2 plus x3 minus p plus obviously x5 minus p. So if you cut everything down, it's just x5 minus p if you are taking something here. Okay, like let me write it again. It will be, if you cut p here, it will be x3 minus x2 plus x5 minus p, right? So obviously if you want the best answer, it means you want to increase the p, right? So the p should always not be x2, it should be x3. It means that we are proving this, hence proved that p should be an endpoint. P should be at the endpoint of some line, endpoint of the line. Okay, we have proved it in the video by various different example, by various different examples we have proved it that the final optimal point P should always lie on some endpoint of a line. See guys, even before this solving this problem, I knew this thing. Why? Because I have past competitive programming experience. In these intervals and lines problem, the answer is always at the end point of the line. I'm just trying to prove it so that you guys can can be satisfied by what I'm saying. Just assume, what if the point was here? What would be the equation? I'm writing a p here. The equation would be p minus x4 plus p minus x2 plus x5 minus p. So p would get cancelled and the answer would be uh, p minus x4 minus x2 plus x5. x4, x2, x5 is constant. So it is what, p minus x4 minus x2. So what you can do is either write p as x4 so that this term cuts out, or either write p as x2. Okay, so like again you have, okay, this we are not even using, right? We are p is here, so it means that the best possible choice to destroy the answers is that you set p as x4. So guys, it comes to us because if you set p as x4, then x4 will get cut and the answer will be x5 minus x2, and you cannot change x5 minus x2. Why? Because these are constant numbers of constant lines. Hence proved that by given various different examples, we have proved it that the final optimal point P should lie on some endpoint of line P. So guys, always remember that these guys are not like fools. Okay, if you, this is the line at x1 and x2 and your point is P here, they will only take the, what is the distance of this line to this point? It means the minimum distance. The answer is P minus x2. Never say that bhaiya the distance of this point from this line is p minus x1. This is wrong. This is not minimum. You have to check for the minimum, which is the closest point of that line. That should be your particular answer. Okay, always remember this thing. So guys, now it is clear that answer will be always be some endpoint of a line. So let's just say, like I also teach this thing in my DP, that whenever you're trying to solve the problem, just think what will be the answer for some particular index. So guys, let's say you say that the your point is p here. Okay, then what will be the sum of the distance? What will be the sum of the distance if your point, acha, let me explain it in a even better way. If your point let me go, if you say in a random space that this is my point p, okay, you say this is your point p, then what will be the answer to this, like what will be the sum of all the distances from point p? How to calculate, the second question is how to calculate the sum of distances of all points from p. How do you calculate that? Guys, it is nothing but common sense. Obviously there would be many lines here, right? Line L1, then there would be line L2, and this would be x1, y1, x2, y2. Answer is nothing but what? P minus y2 plus p minus y1. So the answer for the left part, if you want to calculate the sum of all the like the sum of the distances of all the lines which are coming on the left side of the point, so the left sum is nothing but uh, p into n, p into g minus sum of all end coordinates of lines which are less than p. Okay, so try to understand what I'm saying here is that uh, left sum for point p is nothing but what? Say there are assuming there are g points, g points whose assuming there are g lines, whose end point, just assume guys that there are g lines whose end point is less than p, then the answer will be what? It will be p minus x1 plus p minus x2 plus p minus x3 plus till p minus xg. This is nothing but p is coming for g times. So this is p into g minus sum of all numbers from 1 to g. X1 plus till xg. Okay. So that's why I'm saying that for answer for the left part is nothing but pg minus sum of all these coordinates x1 to xg such that all of them are less than p. So you can easily do that guys. Just take all the x coordinates, put them in an array and sort them. Then you will get the all these things in a sorted manner and you can calculate the answer for each point p. Okay. This is the left sum. What will be the right sum? This is also common sense. Right. Okay. Right sum for point p. So guys, right sum for point p. So what would I do if this is my point P and I want to calculate the right sum? What is the right sum? So guys, all the lines must be having some start coordinate as well, right? X1, then something here, then this line to L1, L2, this is having start coordinate X2. So all the lines which are having start coordinate greater than P, just subtract them. So the answer is X1 minus P plus x2 minus p. So right sum is nothing but uh, x1 minus p plus x2 minus p, all g lines such that their start point is greater than p. So this will come out to be same thing guys, x1 plus till all this sum till xg. Okay, or xg minus p into g, so just the opposite of the above. So guys, like this I will calculate left sum plus right sum for every point p. For every point p guys, you calculate right sum and find the minimum, and find the minimum. That is the best answer for all x coordinates. Similarly do for similarly do for y coordinates and find the best minimum answer. Final answer will be best answer from x coordinate plus best answer from y coordinates. This is it guys. Okay, the problem is very difficult. I'm hoping that the people have like understood the question properly first. Okay. So now, guys, what do we do in the end? There are many lines, right? Like this, like this. There are so many lines given to us. Just assume that we only have the x coordinate. Forget the y stuff. So how will you traverse this? Put all these x coordinates in an x array or x vector. Put all these x coordinates in an x array or x vector. Because we know that the answer can only be the endpoints. That's why I'm putting only the endpoints in my vector. Okay. So you will have an array of x which is having all the x coordinates. Okay. Then for each point, do what I said. Calculate the right sum and the right left sum. Whatever left sum, right sum you get for each point, add them and then try to find the minimum of all those points. That minimum will be the actual answer. Okay. Now I will explain you this thing by the code. Okay. So guys, what am I doing? Okay. So I took the integer n as input. Okay, very good. Then I have these, I'm taking the input of 4 points of each line, x1 y1 and x2 y2. See, I read them. I am pushing the starting coordinate in start x array or start x vector. I'm pushing the end coordinate in the end x array or end x vector. And I'm pushing all the start and end in one common x array or common x vector, which is x. Okay. Similarly, I'm doing for y. Then I'm sorting the x array. Okay, so sorting the array of x which is only having the starting x coordinates, and sorting another array of x which is only having ending x coordinates. Okay, why I'm doing this? So I can do binary search and quickly find the values from x1 to xg. Then I'm creating the prefix and suffix sums. These are also necessary because if I don't create them, how will I know the sum of x1 to xg or x1 to xg in O of 1? So guys, in this problem, we are doing a sorting. So it will take O of n log n time. Okay, the total time will be O of n log n. And then we are just running one loop and trying to calculate the answer. So guys, you can see, this is the most important while loop. What I am doing, I'm iterating through all possible points. I'm just writing here, iterating through all possible points. Okay, iterating through all possible points. Okay, now I'm trying to calculate the left sum and the right sum. This is the left sum, this is the left sum, and this is like, okay, let me write here, this is the left sum, I'm writing it as L sum, and this is the right sum. Okay, this is the left sum. This line number 149 is the left sum. Okay, line number 149 is the left sum and line number 155 is the right sum. I add both of them to pp variable. Then I just do min x equal to mean of mean x comma pp, because I want to find the minimum pp value over all the points. Here I'm iterating through all the possible points, calculating pp for each point and then trying to find the minimum pp. That minimum pp is nothing but the best answer for all the x coordinates. Similarly, I do for the y coordinate and the final answer is min x plus min y. Best answer for x coordinate plus best answer for y coordinate, and that's how you solve the problem. No matter where your x coordinate is, the final answer will be calculated by considering which x coordinates of which lines were closer to you guys. Okay, so always remember that thing. Now, the thing is, I have used binary search to do this. Okay, we can see the two binary search functions as well. So this problem involves greedy strategy, binary search, and even a little bit of hashing because you're making prefix sums. So it involves greedy, binary search, hashing, and geometry as well. Such a nice problem, like total delight in holy. Okay, so now let me tell you why am I doing binary search. Okay, so guys, when you were at point P, what were you saying for the right sum? For the right sum, you guys are saying that you want all the x indices, all the x's. You want all the x the such that x is greater than p. Only you want only those indices or those values of x which are greater than p. So what I did, I made an array of x. I made an array of x, and this is sorted. Okay, then I quickly do a binary search and find which are the coordinates, like from which coordinates they are greater than p. Suppose from here all x start coming which are greater than p. It means xi is greater than p, xi plus 1, all these are greater than p. Then all I need to do to calculate the answer is p into g. Wait, where was it written? It was okay, sum of all these numbers, it is nothing but sum of all these numbers minus p into g. P I already know, g I will come to know. If I know this index, I know how many numbers are from year to year. Okay, n minus index. So g I will calculate. What is the sum of all the numbers from xi to xg? This you can calculate by maintaining the suffix sum array. In O of 1 you will get. Got it? So I will be like traversing through all these n elements, and each binary search will also take log n time. So n log n into O of 1, which is n log n only. So n log n here and n log n there. It is 2n log n, but you can ignore the 2 part and say n log n. Actually, there are 2 points, right? So even the last x array, this array which you are seeing, its size is 2x. Why? Because you are putting, see, why? Because you are putting the x dot pushback x1 and x dot pushback x2. You're putting both the points in x, right? So what you have to do is put both the points. So that will, you're doing this for n times, so it will be 2n. So it will be 2n log n plus n log n. Or if you consider this also, this log n, this log n, 1 2 3 4 5 6, it is 6n log n basically. Now, why did I take the different arrays also for the start coordinates of x and end coordinates of x? Because when I'm trying to find the right sum, I only want those x coordinates greater than p, which are the start points of some array. So I will do all the binary search only on the array which is having x coordinates, array which is having, do binary search, do binary search do binary search on sorted array of x coordinate, do binary search of on sorted array of x coordinates which are starting x coordinate, not the end one, because the starting coordinate will have the least distance from point p, because any starting x coordinate on the left side will have minimum distance from point P. Okay, guys. Similarly, for the left one, if you guys use common sense in coding, the most important thing is common sense, nothing else. So in the left one, if you are here at point P, okay, now you will only want to consider the guys. See, this is a line L1, this is a line L2. You only consider the points which are coming at the end, which is x4 and x3. So the suffix sum or the prefix sum which you will use will be of the last end point. So do binary search. Let me write binary search on sorted array of x coordinates which are strictly end coordinates of each line x. Guys, just like you did for x, you do again for y. Calculate min x plus min y and you'll get the perfect answer. Like if I run this code for this test case, it is giving me 4, which is correct. And for that upper test case, you can see the answer should be 3. So if I take this test case and run, the answer will be 3. Okay, guys. So this problem involves many concepts, but your knowledge of interval problems, which are asked in greedy a lot in ON interviews, which should be clear. Most of the YouTube's influencers, LinkedIn influencers will not teach you these things, because these things require high level thinking skills. Okay, so guys, please try to improve your OS skills, try to give as many contests as possible, try to formulate a revision strategy just like I teach to my students, and be responsible, and one day you will surely get success. Okay, so for now I am really tired, I want to now enjoy the Holi, so I am stopping the recording. I hope you guys enjoyed it.